What's an inverter? Inverters are employed to change direct current, DC, to alternating current, AC. Normally, a power inverter has two input terminals for connecting the DC source, positive terminal and negative terminal. At the same time, the AC output terminal of the inverter provides the AC power for consumers. Inverters are applied in a variety of applications, such as solar systems. You will normally find switches to turn the power on and off, and DIP switches to change the voltage and frequency of the output, and a port for communication. This can be a Modbus communication port or any other type based on the manufacturer. You will also see the cooling fans, which help to cool down the inverter when the internal temperature rises, and a plug, which provides AC power for the consumers. Some inverters come with USB output and can be used to charge a mobile phone, for instance. Based on the size, circuit topology, and the working frequency, inverters are categorized to high-frequency and low-frequency inverters. High-frequency inverters have over twice the number of components and use multiple smaller transformers and have a decreased capacity for long-term exposure to high surge loads like pumps, motors, and some high-torque tools. Low-frequency inverters have robust MOSFET and a large boost transformer that can operate cooler. Thus, they can tolerate higher amounts of surge power. However, an inverter can produce different waveforms: square wave, sine wave, modified sine wave. A pure sine wave output is desirable because many electrical products are engineered to work best with a sine wave AC power source. To understand how an inverter works, let's have a look at its simplified block diagram. Let's assume we have a battery, and this is inverter, and we have an AC consumer at the output. In this simplified circuit, the DC source is used to power the AC consumer, which is a lamp here. With the aim of switches, we can generate AC pulses. If we open and close switches in pair, we can force the current in an alternating direction through the lamp. As you can see, if we open the switches 2 and 3, and then open switches 1 and 4, this will cause the current to flow in two directions through the lamp. So actually, the lamp is facing an alternating current. The lamp will experience this as a square wave. This is not how the current is supposed to be. We prefer a sine wave instead of square wave, as the sharp edges might damage the consumer or cause heating problems with the consumers. Most of the appliances even won't work with DC waveforms such as computers, network switches, etc. In other words, we need a smooth current. The electricity provided by the power grid is sine wave with the frequency of 50 or 60 Hz. This means that the current direction is reversed 50 or 60 times in a second. Actually, the working principle of an inverter is pretty much the same. However, a set of electrical components such as transformers, transistors, and etc. are used to provide the smooth current at the output. To better understand how an inverter works, let's look at the interior parts of it. Basically, PCB can be divided in 4 main parts. The whole procedure is to take a DC input here and deliver the AC output here. At part 1, switching occurs and the square wave is generated. So instead of mechanical switches described, electrical switches such as FETs and IGBTs are used to perform switching. These elements usually have a high-frequency switching capability. They require control pulses to switch on or off, and these pulses are generated by a control circuit. At part 2, there is the high voltage rectifier, and it is for boosting the voltage and preparing it for pulse width modulation. Part 3 and Part 4 provide the control signals and prepare the pure AC output. This is provided by sine pulse width modulation. Let's have a look at a simplified concept of PWM. If we change the time and duration of the switching, the output wave will change. By opening and closing the switches of varying length of time, the average power will form a sine wave pattern. Energy storage elements such as inductors and capacitors help to do filtering and smoothing. The more quick and precise the switching, the smoother wave you will get. Controller board controls the amount each switch is open, and with that, it adjusts the voltage and frequency. So in general, this was how inverters work.